Okay, so graphing inequalities. So when I'm graphing, I want to think like this that we did in grade 10. Y equals mx plus b. The y has to be alone, and we know that because when we graph in our calculator, we only can push y equals. So, all right, so let's try to work to get y alone. So I'm going to go 2y. I leave the y. So 2y I leave. Now I'm going to write the x part, but the x part is getting moved. So negative 6x. And then I write the number 10, and it did not get moved, so it stays. Then to get y alone, I'm going to divide by 2. So I'm going to type this into my calculator, my y equals. I'm going to do brackets and then that divided by 2. So I will let the calculator do the algebra for me. So I moved the x, kept the 10, and divided by 2. Graph. Okay, I'm going to hit the trace so I can find a few points. So 0, 5. And 1, 2 is another point. So 1, 2. So that I found using the trace, and I can tell my mouse to move to a few spots. Okay, now what do I do with this line? Is it a dashed or a solid? Because this says greater than or equal to. So if I can be equal to, then I am a solid line. And then the greater than, you have to pick which side do you want that's greater than. So this side angles upward. And I'm allowed to be any real number on that side. Okay, next. So I'm going to do the same kind of strategy. I'm going to keep the y. So negative 2y I keep. Greater than. The x part I'm going to write next, which is moving the x. So now I would move it. And then if I move it, it's positive 2x. And the 14 stays where it is. So I moved. That's all I did there was just move. Then I'm going to get y alone. So I'm going to divide by negative 2. Ooh, what does it do to us when we divide by negative? Do you remember that rule? Something happens to the sign. When you divide by a negative, it will flip. Okay, so now I'm going to go into my calculator and I will type that into my y equals. So bracket 2x plus 14 divided by negative 2. Okay, so I graphed it, so I need a few points so I can graph it on my paper. So trace, okay, 0, -7. Now I can find, I don't know, -1. So -1, comma, -6. So there's 2 points. That shows me where it's heading. What kind of line am I going to draw? So your options are dashed or solid. So this says less than, so that's dashed. You can't be on it. And we flipped the sign. So now that reads less than. So which direction is less? That will be heading in that direction now. And this time, something different. It says that x and y can only be integers. So if I can only be integers, I'm just going to show you that by drawing a little bit of stippling. Okay, that's enough to show you that, hey, I'm only picking the integer numbers in that zone. Obviously, it will take me forever if I want to draw every single one. Okay, so we're going to do that. Same idea, but now this time I've put 2 lines. Okay, first line, ready? Let's practice. Keep the y, move the x, leave the number. So all I did there was move 3x to the other side. And now I'm going to take that and divide it by 2. So that's what I'm typing in. I'm going to have to divide it by 2 yet. Okay, so if I graph it, 0, -1, and then I can keep moving my mouse. I didn't really like the 1 because it's a half, kind of a decimal, so 2, 2, -4, I like that. The symbol says greater than or equal to. So now I decide if it's going to be a solid or dashed. So solid line. And greater than is going to be that direction. Okay, the other line. Same idea, keep the y, so 2y, move the x, keep the number. Okay, so you line it up, the y, the m, x, the b, line them all up. So I had to make a move. And then I'm going to have to divide by 2. Okay, there's no flip because I don't divide by negatives, so that's all good. So now if I graph that one, so -x plus 2 divided by 2. Okay, so trace, I get 0, 1. One comma a half, I'm not going to do that. It's 2, 2 comma 0. So it goes through those points. This one is also a solid line because it says I'm allowed to be equal to it. Then I have to be less than it, so I'm angling below it. So which space is working for both of them? And also I can't forget that when I'm there, I can only take integer numbers. So this is the space that's working, and the integer numbers in that zone are the ones that work. Okay, last one of these. So I'm going to leave the y less than. I'm going to move 4x. And I don't have to do any dividing, so that's nice. I can just type straight into my calculator. So trace gives me a 0, 2, so that's a point. 1 comma negative 2 gives me another point. So I can find a bunch of points by hitting the trace. And this is going to be a dashed, because I'm less than. I'm not allowed to be equal. So dashed. And I'm less than, so I have to decide which side is angling less than. Okay, when you see on the next one, when you see one of these lines with only one variable, so this one only has a y, it doesn't have an x. There's the other type that has the x but doesn't have the y. Remember, those lines are special. They're either straight up and down or flat. So if you forget, draw me some coordinates that have a y value of negative 2. So a y value of negative 2. You can draw me any coordinate with a y value of negative 2. So therefore, it's going to form a flat line. And it is dashed. And I have to be greater than it, so I have to be above it. And this one says I can be any real number. So I can be anything in this zone. Okay, is this a solution? So we're going to plug this in. So instead of, okay, this is x and this is y, right? When you do a coordinate, x, y. So 11 is going to go in for the y. Okay, this is tricky. You're going to have to think, what's the negative of negative 3? What is the negative of negative 3? So that's 3. Is 11 greater than 11? That's what we got to. Does that work? No, 11 is not. So this will not be a solution. Okay, is 1, 5 a solution? So I'm going to replace, the x gets replaced with a 1. The y gets replaced with a 5. So 3 minus 10 makes negative 7. 3 minus 10 is negative 7. Okay, so now ask yourself that. Is that true? Yes or no? Is negative 7 less than or equal to negative 4? Yes, that is. So that will work. Okay, this time I'm going to replace x with 0, and I'm going to replace y with 0. So all of that math comes out to 0. 0 times anything. And then you have to answer, did that work or not? Is 0 greater than or equal to 14? No. A student was asked to complete this question. The question said, is this point a solution? Is that point a solution to this? And so they plugged it in and they said, well, if I plug in the x and the y, and then I got 2.5 is less than 14, so therefore they said, yes, it is a solution. So what is the idea that they forgot? They forgot to think about something, which is why their answer is wrong. And this is what they forgot. It says that x and y have to be integers. And that y is a half, which is not an integer, so therefore it's not acceptable as an answer. Okay, is on a graph a solution? So the first one is 2, negative 3. So I would be right here, 2, negative 3. So that's in our shaded zone. So yes. Is 1, 1 a solution? So 1, 1, that's right there. And it's actually located right on top of that line, and that line is dashed. So would it be a solution? No. If you're on a dashed line, you're not a part of the solution. If you're on a solid line, you're part of the solution. Is 1, 4. So 1, 4 is over here. Is that a solution? No, it's not in the shaded. Okay, question D, we didn't do that. Okay, number 7. A fruit farm is planting apple trees and strawberries this summer. So that's our two variables. Apple trees, strawberries. Those are our two variables. Actually, I'm going to go, they're apple tree acres. Looks like we're going to talk about acres. So that's how many acres of apple trees we're going to plant, how many acres of strawberries we're going to plant. Okay, what do we know about our variables? So what are the restrictions? Can you be integers? Can you be whole numbers? What? When you talk about acres, well, can acres be negative? No. Can acres be something like this? 2.7 acres. Does that exist? Yes. So all we're going to say is that they have to be greater or equal to 0. They don't have to be whole numbers. We don't have to have exactly 1, exactly 2 acres. You can have 1.2 acres. You just can't have negative. Okay, they can't use any more than 20 acres. Altogether, you can't have any more than 20. So if I add the apples and the strawberry acres, so all the acres together cannot be more than 20. How do I write that? Cannot be more than 20. You can't be more than 20. Okay, they want at least 3 times as many acres of strawberries as they do for apples. So strawberries is bigger. So the strawberries are going to be the same as, we're talking, triple the apples. So I told you all the time when you read that, the 3, when you read it, the 3 sounds like the strawberries. The 3 will go on the apples. So the strawberries, so if I plant 10 apples, then this will have to be 30. That's what I always do to double check and say, oh, that makes sense. How do I write this? They want at least that. They want at least. Then that's that. Okay, when I'm picking which one to put on which axis, I do this kind of thinking. Because this is easier, instead of doing x and 3y, it's easier to do the y. So I'm going to put the strawberries on the y. And the apples on the x. Okay, I'm going to go up to 20. So I'm going to do 5, 10, 15, 20. Okay, to graph this first line, I'm going to take turns making the other one 0. So if strawberries were 0, I'd have 20 apples. So that's 20 apples. If apples were 0, I would have 20 strawberries. So I'm going to draw a solid line, and I will be below that. Okay, so the strawberries are tripled the apples. So can I give you 1 point to write? So if this apple was 5, if the apple was 5, how many strawberries would you have? You have to be triple that, so 15. So we would have the coordinate 5, 15. And we would be going through that. And that is going to be where they intersect. Because 5 plus 15 makes 20. So that is the intersection. And we have to be greater than that line. So we end up being here, and when I get all my intersection points, that's what I get. Okay, let's do the money now. So we have each strawberry is 23 tons, and each ton costs that much. So I'm going to times those. So 23 times 42.50 means 97,750 for each strawberry acre. And then apples, each acre produced 15 tons, and then each ton is that much money. So I'm going to times those. So $27,000 per every apple acre. That's the revenue that I make. Okay, so which point makes the most money? So out of those 3 points, so obviously 0, 0 is not going to make us the most money. So if we had 0 apples and 20 strawberries, if we had 0 apples and 20 strawberries, we would make we would almost make $2 million. The other option is if I do 5 apples and 15 strawberries. So that's not as much money. So my best option is just to do everything with strawberries. That's the best option.